All right, so basically, when you're dealing with simultaneous equations, what you have to do is you have to try to find where two functions would intersect. In this case here, we're talking about simultaneous equations, and we're going to involve quadratics. Now, quadratics, remember, that's any function that is represented by some kind of quadratic, in which case it's going to be a parabola, either a smiley face or a sad face. And we can have simultaneous equations, let's say type 1, where we have a parabola or quadratic and a straight line. And in this case here, what we have is the possibility of them intersecting in three different ways. So the first thing is we have a parabola, let's say random parabola drawn, and we have a straight line which is drawn alongside it. So let's just say whatever. Let's say this is a straight line over there. We have that option, and in this case, you can see we end up with two solutions over here. So we'll end up with xy and xy, and we'll have two solutions for x and y. So that's four values, two x values, two y values. All right, so this will have two solutions. And then you have the option of dragging that entire line such that it forms some kind of tangent. All right, it'll form some kind of tangent. And if you get a tangent which gets you some x, y value over there, that'll give you one solution. One solution. And that's when it's a tangent. And then the third option is you have a straight line which goes straight through the outside and doesn't intersect anyway. And in this case, you'll have no solution. This one here, you'll have no solution for that. This is your y-axis, that's your x-axis. And you can see this doesn't even reach the parabola. So this is type 1 where you have some kind of straight line, and you can have two solutions, one solution, or no solution. Let's look at type 2. Type 2, you have a parabola and another parabola. So whenever I say parabola, I'm basically talking about the quadratic. So parabola and a parabola. And in this case, we basically would have these possible options available. And if you shift the parabola around, in how many different ways can you find solutions of it? So here we go. This is the first one. I've got a parabola drawn over here, and I have one that's basically somewhere else but cutting through a single point over here, xy. I can also have a parabola which is going the other way around. So I can have one that is going the other way around. So let's say like that. This is when the a value is negative. It becomes a sad face. And that will give me two solutions for this. So this one here will be one solution. This one will give me two solutions. And a solution is where they intersect, the ability for it to meet. And then the last option is where, exactly like the third one there, we end up just maybe meeting at a certain point. Actually, there's another option after that. So this is where they could meet at a single point. And then the last option then would be where they don't intersect at all. Right, where this is the original. And this one would have no solutions. This one would have one solution as well. And here we got parabola and parabola mixed up together. Let's have a look at the first type, right? So we're going to look at an example of the first type, so type 1. And let's say we randomly choose two equations. Okay, two equations. We got our parabola equation, which is given as, let's say, negative 9x squared plus 1 equals y. And we've got the straight line equation, which is given as y equals to 2x. Okay. Now, I don't have to draw it. I just have to solve it simultaneously. So if I go straight into a solution, because we're going to be trying to solve for x and y where they intersect, I can see that both of these functions are equal to y. So I can have negative 9x squared plus 1 equal y by equating the functions. All right. So in other words, 2x. And then I can bring 2x onto one side or bring everything else onto the other side, making, let's say, the left-hand side equal 0, keeping 2x there and negative 1, and now trying to solve for x. And what I notice is that this doesn't look like it can factorize. When something can't factorize, when you have a quadratic that can't factorize, then we use the quadratic formula. And the quadratic formula is used to solve any quadratic. It doesn't have to be because it can't factorize, but you can use it on any quadratic. You get b squared minus 4ac over 2a, where in this case, a equals a 9, b equals 2, and c equals a negative 1. And we substitute all of that in there. This is where you keep your calculator handy. And so x takes on the value negative b, which is negative 2, plus minus the square root of b squared, which will be 2 squared, minus 4 multiplied by 9, multiplied by negative 1, all divided by 2 times 9. Now this is a separate skill that you have to develop as well. And you can also tell if you have positive or negative roots. If this number inside this ends up as a negative, if b squared minus 4ac ends up as negative, that means you can't square root a negative. That means they won't intersect. That means you'll have this Z-shaped graph because a is less than 0. And you'll have a straight line and they won't meet. If this square root over here ends up as 0, they will touch at a single point. And if it is equal to a positive number, not 0, then there will be two solutions because of the plus minus. You'll plus one solution minus the other solution. In other words, we're just putting this on a calculator to keep it simple. So we end up with negative 2 plus minus all over 18. And now we're going to square root this over here. And I'm just going to grab a calculator, put the square root button in there, and put 4. 2 squared is 4. 4 plus 36 is going to be the square root of 40. Okay, well, basically 4 and 36, and negative negatives plus the square root of 40. So therefore, I get two solutions for x. I can have negative 2 plus the square root of 40, which I put on a calculator, over 18, and that comes to 0.240. All right, and let's say that's my x1. Then my x2 will become negative 2 minus square root of 40. So we change minus and plus, and we get two solutions. And the second solution is negative 0.462. Now, once you have x values, you can then substitute it into, so now we're going to substitute, we got our x values, it's 0.24 and negative 0.462. We're going to substitute x into y equals 2x to get y. And so from there, we can see 2 times x would be y is equal to 2 times 0.24. So y will equal 0.48 when x is equal to 0.24, or y is equal to 2 times negative 0.462, which is 0.924. So it'll come to negative 0.924. And so for that, I can get two coordinates. The first coordinate over here is x is equal to 0.24 and y is equal to 0.48. The second coordinate is x is equal to negative 0.462 and y is equal to negative 0.924. Okay, and I've now solved it. This is a more complex version because you end up using this quadratic formula. If you divide this into stages, the first stage is we're just equating them. All right. The second stage is we getting our x values by using the quadratic formula, which we can do every single time. The third stage is to substitute it to get y. And that's the three different stages that we're following over here. And here we got a straight line and a parabola. All right, so stage one, we equate them, the two equations. We get it into quadratic form. And what is quadratic form? Quadratic form is y equals ax squared plus bx plus c. So we move everything over to either the left-hand side or the right-hand side, get it into quadratic form. Get a, get b, get c. So a equals 9, b equals 2, c equals -1. And then after that, we're using this, which is known as the quadratic formula. Once we get our x values, we then get y. So this is going to be getting x, and then we get y. So that's step 1, step 2, actually, step 3, step 4, in that order. Now, this is not very nice values. These are decimals, etc. It's stuff that we got to be able to do. And that can come out of a quadratic formula. It's normally when you can't factorize something, it ends up like that. Okay. Now let's look at type 2. Type 2, I have a parabola and a parabola. Let's suppose I have a parabola which is equal to, or given by, 2x squared minus 9 equals y, and another parabola, let's make this one a negative x squared plus 4. Now, we're not asked to draw this, but we can always visualize anything at any point in time. If we remember, or if we know the rules of parabolas, we know that if this value over here is negative, then it's going to be sad-faced. If it's positive, it's going to be smiley-faced. Straight line, this is going to be leaning towards the right because the gradient is positive. But now, we've got two of these. We've got a smiley face and we've got a sad face. And we're not sure. They could intersect at 2 points, they could intersect at 1 point, or they could not intersect at all. And if they don't intersect, that means there's no solution. And that is a solution. It's possible to get no solution. And that's something you have to state as well. Okay, so those are the three options. Let's see which one we end up doing. They're both equal to y, right? I didn't state it in the second one. So if I make the next one equal to y over here, I can see that that and that is equal to y. So I'm going to make them equal to each other because they're both equal to y. I'm going to bring everything onto one side or try and solve for x basically. If I move this across, I end up with 2x squared plus x squared, which is 3x squared. Negative 9 minus 4 will be minus 13 equals 0. Do I need the quadratic formula for this one? Do I need to use minus b plus minus the square root of b squared minus 4ac over 2a? For this one, I can see that my b value is equal to 0. It's not there. There's no x term. I don't need this. I can just solve this. Straight from here, I can take negative 13 over, make it positive 13 on the right-hand side, divide by 3 both sides, get x squared equals to 13 over 3, square root both sides, and get x equals to plus minus the square root of 13 over 3. Again, keep your calculator handy and notice I put a plus minus. Whenever you square root anything, both sides, always put a plus minus. That is always a possibility because the concept of that is if x squared is equal to 4 and I square root both, x can equal plus minus 2, it can equal negative 2, or it can equal positive 2 because negative 2 squared is 4 and positive 2 squared is 4, so we have two possible options with the same result because we're squaring it. So let's put this on a calculator. Let's see what we get. Square root button, fraction 13 over 3, 2.08, or x is equal to the negative 2.08. The more decimals you provide, the better, right? Now, from this here, I'm going to substitute x equals to 2.08 and negative 2.08 into either one of these two. It doesn't really matter. They both have x squared terms. So let's just use the first one. Y equals 2x squared minus 9. All right. So from this here, what we're going to end up with is y equals to 2 times 2.08 squared minus 9, or y equals to 2 times negative 2.08 squared minus 9 as well. And 2 multiplied by 2.08, I'm just going to put this in here, and then we're done with the last part of this here. So I'll put this on a calculator, and the first answer here I get is negative 0.347. And the second one is if the bracket becomes a negative, and you'll find it has exactly the same solution, which is negative 0.347, which is the same y value for two different x values. This will be the coordinate 2.08, negative 0.347. This will be negative 2.08 and negative 0.347. And we can see the y values is exactly the same. And how does this even make sense? If I had to quickly just sketch it for background knowledge, let's suppose I do a quick sketch here at the bottom. What I have is I have a parabola which is going all the way until negative 9. And I have one that's going all the way until 4. Ideally, it's got symmetry. So hopefully that works. And the other one goes the other way around. Something like that, where they both kind of cut at the same y value, negative 0.347. But they have two different x values. The first one is negative 2.08, and the first one is positive 2.08. Y-axis, x-axis. Intersection points over here would be xy. Each of those. Well, the other way around. This one would be there, and that one would be there. Okay. Let's have a look at the next example now. Next one, you give you two equations, and maybe you got to decide now which one to use, type 1 or type 2. So given the following equations, you're given 2x squared minus y squared equals to 14, and 3x plus 2y equals to 3. In this case here, we actually have a brand new type of function over here. In this case, we have y squared involved. Y squared would change the graph. It would change what the graph is and how it would look. So what does the 2x squared minus y squared equals 14 graph actually look like? Firstly, for every time we substitute an x value in there, so if I put 2x squared and I make x equal to 1, to be, or 2, to be amplified by squaring it, minus y squared, which is also going to be, in terms every y value, every x value, is multiplying it by itself. So we end up with a shape that is basically, can be called a hyperbola, or specifically, it looks like a hyperbola. And I'm going to show you a quick image of this now. All right, let's suppose I show you a quick image of this. All right, so I got these two. The first thing I can see is I need to substitute one of the equations into the other. On this side here, I've got some kind of graph that looks like that. And on the side here, I've got doesn't look like it, but this is actually a straight line graph. It'll probably be going this way. So I'm going to rearrange this first and make y the subject of the formula. Then I'm going to change y into whatever I end up with on this side. So I get 2y equals negative 3x plus 3. Divide both sides by 2 completely. Y equals negative 3 over 2x plus 3 over 2. And I can see my gradient is going to be negative. I could rewrite this as negative 1.5x plus 1.5. All right, so now I'm going to substitute this in there. For y. After substituting this in, I can see that I've got negative 1.5x plus 1.5x, which I need to square out. So there's just a bit of simplifying to do here. Here I am multiplying the bracket by itself. So I can use FOIL multiplication. What is 1.5 multiplied by itself? 2.25. So this will become 2x squared minus, let's keep all of this in a bracket and we'll take the negative in last. That'll become 2.25 x squared minus 2.25x minus 2.25x in the middle plus 2.25 equals 14. And let's just neaten up this bracket now, make it a little bit smaller by bringing those two terms down. Negative 2.25 minus 2.25 is negative 4.5 x from there. And this is 2.25x squared plus 2.25 on the side. I'm going to bring the 14 to the left-hand side, make it negative 14. And now I'm going to remove this bracket by taking the negative in carefully. Getting 2x squared minus 2.25x squared plus 4.5x minus 2.25 minus 14 equals 0. That'll get me negative 0.25x squared plus 4.5x and negative 16.25 equals 0. All right, so in order to get 2.25, we take negative, in this case, negative 1.5 multiplied by negative 1.5, and that'll become 2.25 over there because, so we must just remember that 1.5 multiplied by 1.5 equals 2.25. And because we only have 1.5s in there, we end up with 2.25s all the way across. At this point now, you have it in the form where you can extract your A value, you can extract your B value, and you can extract your C value, and you can use your quadratic formula. So I can now use the quadratic formula, which is minus b plus minus the square root of b squared minus 4ac divided by 2a, which I have to now substitute in carefully. B squared is going to be 4.5 squared minus 4 times a, negative 0.25 times negative 16.25. All right, let's not forget we're dividing by 2a. So I got to divide this by 2 times negative 0.25. Now these are a lot of decimals. There's a lot of decimals happening over here. So we would try and do this in stages. We do negative 4.5 plus minus, and let's get the square root into a single value. And the bottom number we get negative 0.5. And once we have it in a more simplified form, we can get two solutions from the stage, step by step, in that fashion, right? So 4.5 squared minus 4 multiplied by 0.25 multiplied by 16.25 and that comes to 4. The whole thing will come to 4 at the bottom here. So that actually factorizes into a nice number 4, in which case we'll have negative 4.5 plus the square root of 4, which is 2, or minus 2 over negative 0.5. Okay, now I'm using this decimals. So the other way that I could have approached this question was keeping it in fraction form all the way through, getting this into a more nicer a, b, and c value, and then maybe factorizing it. All right, let's see we can do that as well. Let's see how we could change this question from here in a different way. But now let's get two solutions here for x. We're still finding x over here. Just remember the quadratic formula gets you x only. So negative 4.5 plus 2 divided by negative 0.5 is going to get me x equals to 5. If I plus it, and if I minus it, I'll get 13. So that's really nice values, 5 and 13. These are not really nice values to work with. So maybe the next possible approach would be to use the fractions instead of decimals, because decimals is a little bit tricky and you've got to be, more precise. So let's say we did that as a possible second method. So we'll call this one method 1, and let's do method 2 exactly the same way. So we're going to have 2x squared minus y squared equals 14. But this time we're not going to use decimals, all right? So no decimals in type 2. Here I'm going to have y equals to negative 3 over 2x plus 3 over 2. I'm going to keep it like that. Then we're going to substitute into here, right? And that's going to become 2x squared minus negative 3 over 2x plus 3 over 2 all squared equals 14. Without using decimals, we end up rewriting this bracket twice again, but this time in fraction form. So from here, I'm going to use the method of FOIL, keeping that all in a bracket, getting 2x squared minus, and multiplying this is going to become 9 over 4x squared minus 9 over 4 minus 9 over 4 plus 9 over 4 equals 14. And I've got 2x squared minus 9 over 4 x squared, and I've got an x term over here and one over here, so that's going to become minus 18. I'll just keep this in a bracket, 18 over 4x plus 9 over 4. Don't worry about how many lines you do this, make sure it's accurate. So the more you write to simplify, the more accurate, less errors you can make. Right? If you do too much in your mind, it can slip up. So writing like this, it's okay. 18 over 4x minus 9 over 4. You want to secure the correct answer at the end. All right, so this is 18 over 4, not 14. And so I can see my common denominator is going to be 4. So if I multiply every single term by 4, then I'm going to end up with the following. 4 times 2 is going to get me 8x squared. 4 times 9 is going to be negative 9x squared. The 4s will cancel there. 4s will cancel here, getting you plus 18x. Over here, negative 9. And then 4 14s is 56. 28 times 2. And so I end up with negative x squared from those two terms plus 18x. Minus 9 minus 56 is minus 65. And if I multiply everything by negative 1, changing all the signs so that I can get that value to be positive, you can see each sign changes. If I multiply this entire thing by negative 1, then I'm going to end up now with something that turns out to be factorizable. And if we go back to our solutions was 5 and 13. And 5 times 13 is 65. So 5 definitely there, 13 definitely there. They both have to be negative because they'll multiply to get to 65. X over here, X over here. So therefore, X equals to 5 or X equals to 13. Now, we did not find our Y values here yet. And we needed to substitute 5 in here and 13 in there as well to get the corresponding Y values for this. So in this case here, I would then substitute 5 into this equation here. So y will equal negative 3 over 2, 5 plus 3 over 2, or y equals a negative 3 over 2, 13 plus 3 over 2. And if I go ahead and calculate that on a calculator, well, it's negative 15. What's negative 15 plus 3? Negative 15 plus 3 is negative 12 divided by 2 is negative 6. This is negative 39 plus 3, which is negative 36 divided by 2, which is 18. So y is equal to 18. And so we get the coordinate, or the final answer for this, to be x equals to 5, y equals to negative 6. X equals to 13, y equals to 18. 5, negative 6, 13, and 18. And we can check if the solution is correct by substituting it in here. If I put 5 in here, and I put negative 6 in here, for example, this is going to be 25 times 2, which is 50. And this is 36, and 50 minus 36 is 14. So that works out. If I put 13 and 18, I could do exactly the same thing. I could put 13 and 18 in here even if I needed to. If I put 18 in here, this will become 36. If I put 13 in here, this will become 39. And I think one of them is supposed to be negative, if I'm not mistaken. So this is 39 minus 36, right? So we should have a negative 13 involved in here. Negative 18 involved in here. All right, so quick check. Doesn't, or we could put this in a calculator. I don't have much space here, but if you had a calculator, you put it in carefully, and you get your negative 6 and negative 18. And that makes sense because if this is negative 18, this will be negative 36, and if this is 13, this will be 39. And 39 minus 36 gets you 3. So proving that that solution is correct as well. All right, so you try this one here. Suppose I've got 3x squared minus y squared is equal to 10. Equation number 1. And equation number 2, I've got 2x plus 3y is equal to 2. Equation number 2. This might not be very nice answers, x and y's. It might be. Just keep in mind the quadratic formula is minus b plus minus the square root of b squared minus 4ac over 2a if you need it when you need it. All right, try it. So the first thing I do is I take my second equation and I make y the subject of the formula. So it becomes 3y equals to negative 2x plus 2. So y equals to negative 2 over 3x plus 2 over 3. If we're going to use decimals, so 2 over 3 is 0.67. So this is going to become y equals to negative 0.67. X plus 0.67. And so when I substitute that in here, I'm going to sub equation, let's call this equation 3 in there. It's going to end up becoming something that I need to square. So we're going to end up with 3x squared minus negative 0.67x plus 0.67 all squared equals 10. I can write this bracket twice. If you can square this the quick way, that's also fine, where you skip this line. Or you can do it the long way, because we're dealing with decimals, it maybe is better. So negative 0.67 squared will come to positive 0.449 x squared plus 0.449 minus 0.449 for each one. So that's first part, remember, was positive, but the next part is actually negative. Okay, so that's positive. Negative times a negative is a positive. That one is negative. So negative 0.449 x minus 0.449 x plus 0.449 equals to 10. And now I'm going to take 0.449 and add it onto 0.449. It comes to 0.898. So 0.449 x squared minus 0.898 x plus 0.449 equals 10. Take the negative into the bracket and try to simplify it. This is squared all the way through, 3x squared. So we're going to have 3x squared minus 0.449 x squared plus 0.898x minus 0.449 minus 10 equals 0. That'll become negative 10.449. This will stay 0.898. And 3 minus 0.449 is 2.551 x squared. So my A value is going to be 2.551. B value is going to be 0.898. And C value will be negative 10.449. And now we're ready to use the quadratic formula. The quadratic formula is minus b plus minus the square root of b squared minus 4ac over 2a. So x is going to be given by minus b plus minus the square root of b squared minus 4ac all divided by 2a. We substitute b in there. Use brackets when you substitute. Always helps. So you minimize that error. 0.898 squared minus 4 times 2.551 times c, which is negative 10.449 divided by 2 times 2.551. That's negative 0.898. And now I'm going to attempt to get this into a single square root, multiplying the bottom by 2. 2.551 multiplied by 2 comes to 5.102. And carefully, using brackets, put it in. Right, so 0.898 squared minus 4 times 2.551 multiplied by negative 10.449 comes to 107.428. This will get me two x values. So using a fraction button, negative 0.898 plus the square root of 107.428 over 5.102 gets me 1.855 as the first x value, and then changing it into negative will get me my second one. which would be negative 2.207. And therefore, once I've substituted this into y, so put that in a calculator now and change x over here into 1.855 and negative 2.207, keeping that on a calculator. So negative 0.67 multiplied by 1.855 plus 0.67 comes to negative 0.573 to three significant figures. Keeping it in your calculator to save time, and negative 2.207 gets you 2.149. 2.149. And so those are the two coordinates I have, 1.855 and negative 0.573, or negative 2.207 and 2.149 as the intersection points that we would expect for this. All right, and that's actually correct. All right, that actually underlines there's a bit of rounding that we just got to take into account. And if the rounding is all good, then it's all good. Otherwise,